Hello, welcome again to Math 253, Calculus 3 here at Cañada College. In this video, we're going to take a deeper dive into section 3.1, vector valued functions and space curves. In this section, we're going to first define the idea of vector valued functions. As you can see, these vector valued functions are very similar to the parametric equations that we've seen, except now we're going to get to take a look at them in 3 dimensions. We can write it with the ij or the ijk standard unit vectors, or you can write it with those greater than and less than brackets that we've been using for vectors. After that, we're going to take a look at the graphs of these vectors. Back in chapter 1, we graphed parametric equations in 2 variables, in 2 components, and we took a look at the graphs on the plane. So these are going to be called plane curves, and we can graph them using our vector notation. But now we're also going to get to graph these things in 3 dimensions, where we have vectors that are going to be part of the ijk standard basis vectors. This is an example of a helix, one of the most popular first types of graphs that we're going to study in 3 dimensions. After that, we're going to take a peek at the calculus of vector valued functions by looking at limits. There is going to be a short definition and some limit laws that we're going to be able to use. And we're going to see that taking limits of these things are simply taking limits component by component. And there are no new interesting rules that are happening. We simply use the same old rules that we've used back in pre-calculus and calculus 1. We're also going to look at this in the context of vectors. And so we're going to apply vectors to limits. We're also going to apply the idea of vectors in studying continuity. Okay, that's the end of chapter 1. That's the end of section 1. Good luck.